Okay, so this is going to be part one of a two-part video series on factoring. So the first type of factoring is greatest common factor, and I wrote it out fully right here. So let's look at our first example. So with greatest common factor, you want to find what all the terms are going to have in common. So what do 12a cubed plus 10a squared have in common? Well, I would say they both have a 2, and they're also going to have two a's. So we're going to divide out a 2a squared. So that's going to leave me, inside the parentheses, that's going to leave me with a 6a plus 5. Because if I were to multiply this 2a squared back in, so 2a squared times 6a, that would get me the 12a cubed right there. Same thing with the 2a squared to the 5. If I multiply those together, then that's going to get me that 10a squared that I had from the beginning. So there's a way to check your work. Alright, so there's number one. Now let's look at the second one right here. We've got more to look at right here. But looking at the numbers first, automatically I can take out a positive 7. Now looking at the m's, the first term has 8 m's and the second one has 2 m's. So the largest number of m's I can take out is 2. So we're going to take out m squared. Now looking at the n's, the first one has 5 n's and the second term has 2 n's. So the most number of n's that I can take out will also be 2. So now what am I left with inside the parentheses? If I divide 14m to the 8th, n to the 5th, by 7m squared, n squared, then that's going to leave me with 2m to the 6th, n to the 3rd. And now for the second term, make sure you keep that minus sign. For the second term, we divided the whole thing out. But you can't just leave it blank. You do need to put a 1. Because when I multiply all this back in, I can still get that 7m squared, n squared. Alright, and just a friendly reminder, when we are multiplying our numbers together, you actually add your exponents here. And then if we were dividing them, you would subtract the exponents. Alright, moving on. Now we're looking at difference of squares. Well, before we try to solve number 3 and 5, let's list some perfect squares. So the first one that you should know is the number 1. That is a perfect square. The next one would be 4, and then 9, 16, 25, 36, 49, 64, 81, and I've run out of room, but you get the idea. Basically, you would just do 1 squared, that would get you the 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, etc., etc. So that's how you would find all of your perfect squares. So the rule, when we are factoring by difference of squares, would be a squared minus b squared. And then when you factor that out, it would look like a plus b times a minus b. So now let's look at number 3. So we got 9x squared minus 49y squared. So with this, essentially I just want to split each of these terms in half. So thankfully 9 and 49 are both perfect squares. So let me go ahead and make my parentheses here. And we know that we want one positive and one negative. So let's split up that 9x squared first. The 9's a perfect square, which would be 3 times 3. So I know we want positive 3 positive 3. And now to split those x's, fairly simple. There's only 2 of them, so we would just split that as x and x. Because then when we would multiply this all back together, 3x times 3x would get us the 9x squared. So now let's split the 49y squared. If we were to take the square root of 49, we would get 7. So we know it's going to split into 7 and 7. And then same thing we did with the x's, we're going to do to the y's. So we're just going to have one y on each side. Because 7y times negative 7y would get me that negative 49y squared. And that's all you have to do for number 3. So now let's look at number 5. This one's a little interesting. With number 5, you actually need to do the greatest common factor first, like we did on the previous slide, and then you're going to do your difference of squares. So let's see, what do 7m to the 7th n minus 28mn cubed have in common? Well, they both have a 7, they both have one m, and they both have one n. So what am I going to be left with inside of my parentheses? I will be left with m to the 6 minus 4n squared. So now, don't forget about the 7mn, we still need it, but now we can do our difference of squares. So, just like we did up here in number 3, we're going to essentially try to split what I have inside of the parentheses. We want to try to split that in half. So m to the 6. Well, 6 can be split into 3 and 3, not a perfect square, but 3 and 3 added together makes 6. So I'm going to split that up into m to the 3rd, and then m to the 3rd. And remember, you want one side to be positive and the other one to be negative. Doesn't matter which side, I just happen to put the positive first. So now, 4n squared. 4 is a perfect square. So the square root of 4, that would just be 2. So we're going to have 2 and 2. And then split up the ends like you did x and y up here in number 3. So then 2n and 2n. And there you go. That is your final answer. Now let's look at sum of cubes. So before we do that, we need to list out some perfect cubes. This would be numbers where if you took the 3rd root of them, you would get the number that they line up with. So, first one being 1 and 8, 27, 64, 125, 216, 343, etc., etc. So you would find each of these by just taking each number and raising it to the 3rd power. So 1/3, or 1 to the 3rd would be 1, 2 raised to the 3rd would be 8, 3 to the 3rd is 27, so forth and so forth. Our rule for sum of cubes will be a cubed plus b cubed, and this is going to split into a plus b, and then a squared minus ab plus b squared. So to solve a sum of cubes problem like number 7, I want to try to split these up first so we can see where those perfect cubes come from. So I'm actually going to do x to the 3rd and put the x inside the parentheses. That'll be important for later problems. Plus, and then the cube root of 27, that would actually be 3. So now we're going to have 3 in parentheses raised to the 3rd. So now let's set it up as follows. So a plus b, so this is our a, This is our b, so we'll have x plus 3. And now for the long part. So you have all of our a's and b's, so we're going to have x squared minus 3x plus 9. Since the 9 would come from 3 squared, the b squared up here. So what you need to do is just find your a and b like we did up here, and then just plug it in to the rule that they gave us in the beginning. So that is the final answer for number 7. Now look at number 10. So, kind of like how we had in number 5, we need to pull out our greatest common factors. So, between 24c to the 4th d and 375c d to the 4th, I can take out a 3. I can also take out a c and a d. And what I'm going to be left with inside my parentheses is 8c cubed plus 125d cubed. Alright, so now just like we did in the previous problem, let's break these two up and raise them to the 3rd power. So bring down the 3cd, you're going to need it in the final answer. Let me draw my little arrow here. And then what we're going to have is, so cube root of 8, that's going to end up being 2. And then we have our c here, it's already raised to the 3rd, so that's convenient. So 2c, both raised to the 3rd, plus, and then the cube root of 125 is just going to be 5. And just like we did with our c, do that with the d, raised to the cube. So now we're going to take these two guys right here and plug it into our rule up here. And I'm going to go ahead and do that on another slide so we have more room. So, like I said, don't forget that 3cd out front, you still need it. And now our a term, 2c is going to be the a, so I'll go ahead and do that. A is equal to 2c, and then b will be equal to 5d. So now, plug it into the rule. So a plus b, that'll be 2c plus 5d. And now, this is the long, complicated part. So now we have a squared, so take 2c and square it, and you're going to get 4c squared. And now a times b, so 2c times 5d, that would be a minus 10cd. And then lastly, we need b squared, so 5d squared, and that would be 25d squared. And then this big guy right here is your answer, your final answer to number 10.